And Cole? Nice. What are your would you do the first one so more about things that you need to say less?
Nice.
Before I decided that
Are they doing a bust you guys' game Wednesday, or are they just saying nobody's coming? Okay. Cool. Stinky Carlos.
is it pages not finished? Screen back into you.
Are we ready? Are you ready?
Ready.
Ask spirit, thinks that response. Okay, here we go. The first one, what do you say? Displacement. There's no unit, so let's just go displacement on time 0 to time 3. Normally you'd include units on the displacement and units on the time, but I didn't give you any. What about the next one? Okay, this is a bit of a gotcha. What is it? It's both distance and displacement. Why is it distance also? This is positive. So this is, that integrating velocity is always displacement. That's always there. But because the velocity is positive over the interval, absolute value velocity is equal to velocity. And so it's also equal to distance. So you'd say, in terms of AP wording, you'd say something like displacement, and because velocity is positive, also distance on 0 to 3. 0 to 5, or 3 to 5, excuse me, 3 to 5. Okay, next one, distance or displacement. Displacement. Would you say that you ended right of where you started, left of where you started, or couldn't tell? Can't tell. Why can't you tell? Because, well, okay, what does the graph tell you or doesn't tell you? What would you have to see in order to be able to tell if you're right of where you started or left? Yeah, think of the areas, relative areas. If the area below was bigger, then you would end right or left of where you started. If the area below was greater, you would move more to the left, and you would have probably ended left of where you started. But above would imply more rightward movement. All right, what about the next one? Distance, that's the big idea. What do you call absolute value velocity? No. What do you call absolute value velocity? Speed. It's the speed. This is important to remembering this because it's the same thing for two-dimensional movement. If you integrate speed in one-dimensional movement, you get distance. And if you integrate speed in two-dimensional movement, you get distance. Same goes with three-dimensional movement. So it's distance traveled on 0 to 5. There's this direct relationship between distance and speed. They go together, and displacement and velocity, they go together. What about the next one there with the fraction? Hopefully when you see a fraction with an integral, your mind goes to average value. That's the average. Is it the average position or the average velocity? It's the average of whatever you see being integrated. So it's the average velocity. It's the average velocity on 0 to 3. When you see a fraction, it's the average value of whatever is in the interval. So with that in mind then, what's the next one? It's the average speed on the interval. What about v at 5 minus v at 0 over 5 minus 0? It is average acceleration. That's change in velocity over time. Well, if you change velocity over time, then you're talking about acceleration. Average acceleration at a point or on an interval? On an interval. Could you use that to estimate the instantaneous acceleration at some point in between? Sure you could. That would be an estimate. What about the last one? What is it? Position. This is position at time. Great. Starting position plus change in position gives you ending position. Start x plus change in x gives you ending x. All right, good deal. Let's go on to today's lesson, which is distance, but without a calculator. So it'll require a little more thinking on your part, but it's not that big a deal, I think. So, as I just mentioned, recall when we don't care about direction, then we deal with what? If you want to remove the direction component, then what are you going to be looking at? There's two answers to that. What? Distance, okay. I don't care if I went right or left. I just want to know how far you went. I don't care which direction. Just how far. What else? In terms of change in position, that's if I remove the sign component, then I'm talking speed. Distance and speed go together. When you accumulate a bunch of speed times time calculations, you get a total distance. If we do care about direction, by the way, let's talk about that. Distance then is saying if you take a lot of rate times time calculations and add them, then you're getting a total distance. Okay? If we do care about direction, then we're dealing with velocity because we have a signed change of position and displacement. Same deal. Displacement is the accumulation of many signed movements. Many rate times time calculations with the sign in there tells me how much did you move negatively, how much did you move positively, and gives me a net total. All right. So this is quite like the one in the back of the book, but or in the you'll see in the book, but it's a good. It's the basic idea. So we'll go with it. So you've got a position function, so horizontal movement over time. Okay? Find the position at time 0 and time 3. Well, time 0 should be easy enough. What's the position at time 0? 1. Okay, some of this is going to involve some arithmetic. For some of you, that'll be problematic because you're a little too calculator dependent for arithmetic. I saw somebody pick up a calculator last week to multiply by 10. That blew my mind. I mean, that's just obviously your instinct is, okay, go to the calculator. That's terrible. At any rate, 3 halves times 9 minus 18 plus 1. Let's go with the 27 minus 18 is 9, plus 1 is 10. 10 plus 27 halves. What's 10 plus 27 halves? 47 halves. Good job. Okay. Now then, if they ask for, this will be pretty common in the book, they'll say, okay, so find the distance traveled. And they're trying to bait you into what a lot of people would do. They say, well, you know the position at time 3 is 47 halves, and the position at time 0 is 1, so I could just subtract the difference. X at 3 minus x at 0 is 47 halves minus 1, or 45 halves. Is that correct? No. What did I just find? I just took the difference in position, which is displacement. That's not distance. So do not fall into the trap of just saying, okay, now I'll just take the difference between the positions. And boom, I'm good. That's displacement. To find the distance, it's actually quite a bit more complicated. You would have to do something like distance equals the antiderivative from 0 to 3 to speed. Now that, on one level, is kind of counterintuitive, kooky. In order to get the distance from the position, I'm first of all going to have to take the derivative to get the velocity, and then I'm going to take the antiderivative to get how much position. So that seems like kooky, doing and undoing kind of work. But the absolute value is really where it's at. It's not really taking a derivative and taking the antiderivative. The absolute value in there is where the meat of the problem comes. With a calculator, would you create that out in your calculator, please? Should I type in what I see, or do I need to do something else before I put it into my integrand? I must take the... Do I have velocity? No. How do I get velocity from position? Derivative. I need to take derivative for velocity. So you're not ready to put in your calculator quite yet, or at least until you at least mentally take the derivative. So the absolute value of 3t squared plus 3t minus 6 integrated. I think this comes out exact. Would you print that out in your calculator? Don't forget the absolute value. Otherwise, you're going to be finding displacement. And what do you think? 29.5. Do we all concur? Okay, now that we've done before. The new stuff for today is how you do that without a factor. And actually is a little more work, actually quite a bit more work, so here we go. Start with the fact that you know distance is the integral of the absolute value of velocity. You will find the velocity function, which we already did, but I'm trying to get you your steps in your notes so you have what needs to be done. All right. Now, if I'm going to integrate absolute value, when we took derivatives of absolute value, what was the approach? Do you remember when we took derivatives of absolute value? So, for example, if I said something like t squared minus 4, and I took the derivative of it, didn't I have to do this in a piecewise kind of way, dealing with the flipped parts and the unflipped parts separately? The same goes here. You must use piecewise. So, piecewise is the next part of this. I need to start probably by sketching it. If I were to graph, let's take out a 3 and call it t squared plus t minus 2, does that factor? T plus 2 and minus 1. So the flips are at -2 and +1. Given that it's an upward opening parabola, probably looks like that. Yeah? Okay. If you're not familiar with the graph, then your focus should be where are the zeros, because that's where you're going to have to, if graph unknown, you have to find the zeros and sign test to see what parts are getting flipped up for negative versus positive. Okay? In our case, we know the graph and we know where it's getting flipped up, so we're all right. Now then, you're actually going to write separate integrals using the pieces. If I were to integrate this, the piece from 0 to 1, remember the original region was 0, 3. So I'm going to use that same region, but I'm going to look at this differently. 0 to 1, is that normal V or is that opposite of the V values I'm giving? Opposite V's. Okay, so when I say write separate integrals, I'm using -V for flipped. Not because I want them to be negative, but because I want them to be positive. They're negative on their own, and I'm changing them to positive, right? The next region is from where to where? 1 to 3, and is that unflipped V, or should I negate V, or just call it straight up V? V, okay. All right, now the good news is I don't have to actually put in V here and there and integrate that. It's a time waster. Instead, use the fact that the antiderivative of V is position in the fundamental theorem of calculus. Fundamental theorem of calculus is basically what do you do with the definite interval? And you find the antiderivative and evaluate at the upper minus at the lower in both cases. Anything? Okay. Now, again, this is all these are meant to be time savers. Would you then evaluate and combine like terms? The whole idea being to minimize how much it is substituting into the stinking function and all this arithmetic I have to do. This is negative x at 1 plus x at 0. And this is x at 3 minus x at 1 if I did fundamental theorem. Do you agree? If I combine like terms, I could say x at 0 plus x at 3 minus 2 x at 1s. And that would at least get it down to 3 things I have to find instead of 4. And now I can substitute in at this point. Substitute and evaluate. X at 0 we know already. It was, I forgot what it was, 2? 1? Okay. X at 3, 47 halves. And unfortunately then X at 1, I do have to find, doggone it. So 1 plus 3 halves minus 6 plus 1. 1 plus 3 halves minus 6 plus 1. That's the stinker of it. Minus 2 times, what do we have there? Negative 5, negative 4 plus 3 halves. So it's negative 4 plus 3 halves. Negative 5 halves, I agree. 1 plus 47 halves minus 2 times negative 5 halves. That's 1 plus 47 halves plus 5. Well, that's 6 plus 47 halves, which is 12 halves plus 47 halves, which is 59 halves. Does that agree with what we found by the calculator about 10 minutes ago? Yes, it is. Whee! All right, you tracking? So the point is, it's a lot more work without a calculator. Thank goodness for calculators, we'll have to do both. Would you try number 3 in the homework, please, by way of practice? Wasn't really my intention, but could you evaluate the integral geometrically with triangle areas? Yeah. If you did that, that's good thinking, but it wasn't really my intention. How's it going? Okay. Yes. Yeah. Because the velocity absolute value got flipped up at 3/2.
Yep.
This would have been otherwise negative. At time zero, this would have been negative, so we're taking the opposite of velocity on that interval. So when you integrate negative v, you get negative x. And the other part after 3/2 was not flipped, so it's just normal velocity. And therefore antiderivative is normal x. Does that answer the question?
Why is x to x of 0 not negative?
Because by fundamental theorem, it's at the first minus at the second, and so that amounts to minus a negative. That's why it's positive. If I took negative x at 3/2 minus negative x at 0, right? We have a subtraction because fundamental theorem, and two negatives then. So something like 4. We got their negative 1/2. So did you get 4.5 for the distance? 9/2? Yeah. What the heck?
That's it.
Okay. All right. Feels like with triangles, you could verify this with triangles, but I think that's correct. All right. That is that. I don't know whether to go back to your notes and do this example, but there's also one in the homework. Maybe this would be nice to have in your notes, so let's do it. Okay. They're going to be, these are problems that are quasi-related, but they tend to stump people when they appear in the homework. So let's talk about it. And again, it might look familiar because I gave you one last week for the extra practice. On Mars, acceleration due to gravity is negative 3.8 meters per second. That Damon throws a ball horizontally at a rate of 20 meters per second from a release point of 2 meters. And it lands 20 meters away. What is the average height of the ball while it is in the air? So he's releasing it from a point of 2 meters high. I guess that's about normal. He throws it horizontally, and so eventually gravity does take hold and pull it down to the ground. The question is, what's the average height of the ball the whole time? It must be somewhere in between 0 and 20 meters or 2 meters. What's the average height? Would it be between 0 and 20 or 0 and 2? 0 and 2. Okay, the original height was 2 meters. The mean height must be somewhere in between here. Now, I would assume it's a little more than 2 because it's going slower, it's falling slower at the top end than it is at the bottom end. So I would guess a little above 1 meter, but we'll see. So, what the heck? The average height. I can't find average height. I could find this if I had a height function, right? Okay. How can I get a height function given all this information? Integration. Okay. I know that acceleration due to gravity is negative 3.8. Now, please do keep the horizontal and vertical components separate for a little bit, all right? The velocity vertically, now remember this is vertical movement that we're going to focus on, would be the antiderivative of acceleration with respect to time. So velocity is negative 3.8 t plus a constant. Again, that's vertical velocity, or the height change in position with time, however you want to call it. I'm just going to keep those two ideas straight. Do I have an initial condition, an initial vertical velocity at a time? Why is it 0? It feels like it should be 20 meters per second. So because that's horizontal, There is no vertical component to his velocity. The vertical velocity is 0 at time 0. Oops, that's y. So that implies that the vertical component to the velocity is negative 3.8 t. In other words, velocity is strictly due to gravity only, not the person's throwing, in terms of vertical. You with me? Okay, now I can find the height. Height is the antiderivative of the vertical component, so the antiderivative of negative 3.8 t with respect to t. What is the antiderivative of negative 3.8 t? Negative 1.9 t squared plus a new constant. Do I have an initial or some kind of time height condition given? Time equals 0, the height is 2 meters. So that tells me that the height equation is negative 1.9 t squared plus 2. Now we're getting somewhere. Okay, now to find the average value of the height, I would normally say the average value of the height is 1 over, well, it's this thing, but I don't know when, over what time interval. I don't know what to put there. How do we find these? Plug 0 into the height. Yeah, we need to find the time it's in the air. So if I plug 0 in for the height to know when it's hitting the ground, it would be the square root of 2 over 1.9, the positive version. Wait. Okay. So now, finally, I'm ready to find the average height. It is 1 over the square root of 2 over 1.9 minus, what's the other time? 0. Times the integral from 0 to the square root of 2 over 1.9 of what? Acceleration, velocity, or height? The height. We want the average value of the height, so we're integrating height. You may use a calculator at this point. Let's calculate that and hope it comes out to be between 0 and 2. I'm getting 1 1/3 meters. Yes? Okay. Which to me makes sense. All right. That's a pretty good look at all the types of problems, and most of the problems you'll see. Which you got your homework from back on Thursday. I do have your test graded. Sorry, hopefully I'll be able to at least show you how you did. If not, I can show you in 7th period or after school. Take it back, not after school, I have a meeting after school. Or we'll go over them tomorrow. So here we go. You have out, or kids, you get out, please, set 89 fun sheet. And let me give you the answers first that I have, and we can then go over questions after. All right, the first, in section 1, the first one we did in class, so that should be good. The g of x, I have an answer of 1. H of x, my average value was 2. And k of x, my average value is 1.2895. So I would take 0.289 or 0.23290. Either one would be fine if you rounded or truncated. Are we good? Okay. Section 2, the first one we did together. This one I changed to how many zeros because there were stinking too many to find. I get that there were 10 C values. How about you? You agree? Alrighty. Maybe we don't. How about this? I have that C is the rather ugly log base 2 of 15 over 4 log 2. If you got that, you might have thought, man, I must be doing something wrong. That's ugly, but it really was that ugly. And for this average value, the C at which the average value occurs, there were two of them, 0.3795 and 2.7620. Okay. Moving along, my average height here is 96 feet. If that didn't go well, maybe now with your notes at hand, you could do better. This, my average velocity was 0. For 11, my average velocity is 8 over 3 pi. 12, I am an idiot. It is not actually possible because I didn't give you an initial condition. To get the average velocity, you would need the velocity, right? The velocity is the antiderivative of acceleration, which is great, but you'd get a plus c, and you don't have any initial condition, and you need an initial to actually answer this. So it is not possible. I apologize. I am done. Okay. This, I think we talked about it. This class we might have got to it, but I'll go anyway just to be sure. This is 13, and that means that time equal 8 days. The student has 13 problems to do. The derivative of n is maybe 2 times pi over 2 times cosine of pi over 2t. At 8 is pi. Interpreting that takes a little more. That time equal 8 days. The number of problems the student has to do is increasing. You cannot say changing. You must interpret the sign of change. So it must be increasing at a rate of pi problems per day. Okay. The NDT is problems per day. So it's the rate at which problems are increasing. He's roughly gaining 3 problems per day at that point. He's losing the fight with his teacher. This. I did it by a whole bunch of USUB and all this, so at the end I have 13. In terms of the interpretation, it is from time equal 2 to time equal 6 days. The average number of problems the student has to do is 13. 13 is the average number of problems he has to do on that time interval. Cool. Okay, moving on to the AP. There we go. Okay, so you've got to, what is this going on here? I forgot. So coffee is filling through a coffee maker into a pot, and this C represents how much coffee is in the pot, the amount of coffee in the pot at different times. You can see it's increasing, so coffee is dripping into the pot. All right, I got it. The rate at which C prime at 3.5. Did you, first of all, I wish you would start to underline and circle approximate, because if you said C prime equals, then you will be losing points right away. Okay, so if that was you, scratch that and say approximately equal to. If there's any doubt, if you are saying approximate, they will not give you the point. If you give some kind of lame, I don't know, I'll do a little mix, that's a no. It's obvious you don't know what you're doing -1 from. Okay, you best be intentional, especially if you're a small writer. If yours is little, -1, I don't care. You don't get a benefit from your small writing. It must be intentional. Okay, so make sure that your approximation is intentional. Make sure that you never go straight to a table. You show where your table values are coming from. You will never get full credit going straight to a table. You must show that. And then the answer is, I got 1.6 ounces per minute. Okay, so if you got that, actually I am great at this. Let's see how I did. What is for the approximation? That would include, in that, they would include, did you say approximately equal to? Did you show where it comes from? And did you get 1.6? All that's the first. If you had those three things, approximately equal to, where it came from, and 1.6. What if you are doing what I consider gutless math, and you don't even say this, if you just do that? Is that okay? It's actually okay. They'll count it. I think it's being a wuss, but whatever. Okay. One is for the units. Do you have ounces per minute on your derivative? Give yourself 0, 1, or 2 there. Questions on part A? Cool. B, is there a time at which C prime equals 2? If you see an existence question, is there a time, and they're talking about derivative, are they probably thinking IDT or MDT? MDT. What are the conditions for MDT? Continuous and differentiable. You must say that if you say MDT, otherwise you're out of a point at least, okay? Do they tell you anything about that? They give you that C is differentiable. Does that imply continuous? If it's differentiable, then it must be continuous? Yes. And so you would say C is differentiable, so also continuous. And by MVT, therefore, there is a C in 2 to 4, actually a T, sorry, they call that T, don't they? There is a T in 2 to 4 such that C prime at T equals C at 4 minus C at 2 over 4 minus 2. Here's where I just hope that comes out to be 2, because otherwise I must be doing something wrong. And does it come out to be 2? It does. Okay? All right. If you had some kind of average value setup, C of 4 minus C of 2 over 4, not some kind of, exactly that average value setup, give yourself a point. If you, first of all, showed the conditions for MVT are met, differentiable and continuous, and then said MVT, then you get the second point. And if you just said MVT, boom, without conditions, you do not get that MVT point. You must show conditions in there to use it. Okay? 0, 1, or 2 there. Are we good? Okay, part C. This is where the work came in. Using midpoint sum of 3 intervals. A picture helps me, but if I'm squished for time, I wouldn't do a picture. Value of. I can't tell you how many people get lost in that evaluation of the integral and forget that 1/6. It gets dropped probably 1/4 of the time. Okay, please make sure that you guard against that. If it's midpoint Riemann sums, then that means 3 rectangles. In this case, if you're using midpoints, then that means you have to skip and use the middle for your height. So it looks like we're going 0 to 2 with our height at 1, 2 to 4 with our height at 3, and 4 to 6 with our height at 5. So in terms of the setup, they would expect you, they don't care much if you show where the base comes from. But the first base is from 2 to 0. The height is C at 3. You must show C at this, C at that. You cannot go straight to the table. C at 1, thank you, sorry, C at 1, not C at 3. C at 1, you must show that, not go straight to the table. The next one is from 4 to 2 and C at 3. You don't have to show that 2 minus 0 piece. If you just said 2, that's fine. But you definitely have to show the C at part. You tracking? 6 minus 4, C at 5. If you did that well, I got 10.1, but I haven't checked my answers. I got 10.1. What do you think? Okay, what's the meaning of this? When you see a fraction in front of an integral, you should think average value. Then you just take what they call it. This is the average value of, if you want to say value of, you can say that, but you can also just say the average value of, what's C? The amount of coffee in the cup. The average value of the coffee in the cup. I'm just going to remove the value and say this is the average amount of coffee in the cup. You could say average value of the amount of coffee in the cup. The basket's fine, Chief. Coffee in the cup. Now there's still 3 other things they're looking for. Units on that, in ounces, and time with units. From time 0 to time equals 6 minutes. Just like any integral interpretation, they look for 4 things. What it is with units, when it is with units. Amount of coffee, average amount of coffee in the cup. You could say average value of the amount of coffee in the cup, whatever. And so the point values were this. 1 point for the midpoint sum. That's basically, do you have the correct bases and identifying where the heights came from. If you have that shown, then that's a point. 1 point was for the actual answer being correct.
Please rise for the Pledge of Allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
And then 1 point for the interpretation.
Whose last names start with A through F will be required in counseling today during the 7th hour at the auditorium. We will be focusing on...
Give yourself 0, 1, 2, and 3, and I'll put up D.
For students interested in AP Computer Science, there will be a short informational meeting in the computer lab 7202 during 7th hour Tuesday. All are welcome.
So that's just the derivative there,
Have
yeah?
you checked out the trendy Volterra bracelets at lunch? Get yours for $5 outside the lunchroom to support Latin American artisans and enter to win a Starbucks gift card.
Hey, all aspiring runners, jumpers, and throwers, it's not too late to join the track and field team. Get your paperwork in as soon as you can and join us at practice today or anytime this week. Questions? Ask Coach Bell or Coach Porter.
Boys swim team will be meeting in the senior lounge at 2:30 before we depart for practice today.
Attention girls golf team practice for today. Tomorrow is canceled due to the snow we had at the end
Okay,
of last
1 for the derivative before putting 5 in, and 1 for the derivative with 5 in.
Choose the winner of the Dash
Anytime you
T-shirt
take a
logo
derivative, you should
contest.
show the derivative first, then the number going in.
Please stop by the office and pick up your $50 Starbucks gift
Give
card.
yourself 0, 1, or 2 there.
Course registration materials will be collected this Thursday during 7th hour. Please report to your first period teacher on Thursday to 7th hour and bring your course selection summary sheet with you with signatures, your math teacher and a parent. If you are signing up for an AP class, you also need to complete an AP contract. AP contracts can be obtained from the counseling office.
Senior high students, today during the 7th hour, a scholarship workshop will be in counseling for seniors. You will have the opportunity to work on your own
I
and
don't know if
select
there are
the
questions
courses of
on
the
anything
day.
else. I can
Scholarship
do.
deadlines are rapidly approaching.
Just a reminder that all NHS forms are due for prospective members today. Please get them to Ms. Ford or Ms. Stevenson ASAP.
Don't forget tomorrow is College Drive SAT test prep class at 1:45 p.m. in room E100 in the Math Hall. It's not too late to register for Summary Counseling if interested.
There will be a senior high student council meeting today, and Mr. Willis
Dad, what is that? Congratulations to the boys and girls basketball teams for advancing to the Sweet 16 wins over the weekend. Girls play Tuesday at 7 p.m. at home versus Golden. Boys take on Falcon High School Wednesday at 7 p.m. at Falcon High School. Good luck, guys.
The boys game on Wednesday is going to be in Colorado Springs, so if you're interested in riding in a fan bus down to Colorado Springs, please talk to Mr. Zimkinen at his office. You need at least 35 students to have one. That's all your announcements. Have a great day.
So you're learning stuff.
Hold on.
All right.